Bytes. So I hope all of you are doing good and your preparations are going nicely. So hello Tanya, Farheen, Aditya, Jyoti, all of you welcome to the session of NEET Bytes. So today we'll talk about mainly electromagnetic waves and we'll see some of the questions that have appeared in previous year NEET exams. Okay, let's move forward. So, firstly, I'll introduce with all of you with electromagnetic wave. And as you all must have learned about electromagnetic waves, you know, in electromagnetic waves, electric and magnetic field they oscillate in the direction perpendicular to the direction of propagation. Electromagnetic waves are transverse types of waves. So I hope you know about transverse waves. In these types of waves, electric and magnetic field they are oscillating in the directions perpendicular to the direction of propagation. If this is the direction of propagation, so yes, this is the direction of propagation. Yes, exactly. So next thing, one very important result that we know about the direction of propagation. The direction of propagation is determined by direction of propagation is determined by E cross B. Okay, E cross B. The cross product of E vector and B vector is the direction of E cross B will show you the direction of propagation. Okay, so one thing you should know that if we have I cross J, we'll get K cap. As you must have learned about I, J, and K, they are the unit vectors for X, Y, and Z axis respectively. So if you cross multiply I cross J, you'll get K cap. If you multiply J cross K, you'll get I cap. And if you multiply K vector and I vector, you'll get J cap. So this is the thing that we are going to use right now. And yes, if you have something in opposite, like suppose if you break the pattern, suppose you take K cross J, then you will get minus I cap. Okay. If you take J cross I, it will be equal to minus K cap. Similarly, if you take I cross K, it will be minus J cap. So next thing, let's see the question. The electric and magnetic field associated with an electromagnetic wave propagating along Z axis can be represented by. So the direction of propagation is Z axis. Okay. So Z axis is the direction of propagation. That means K cap is the direction of propagation. Next thing is E cross B. E cross B will tell you the direction of propagation. Okay. Now see the previous combinations in which you are getting plus K cap. only in the combination I cross j you're getting k cap. So I cross j is k cap. So plus z means plus k cap. So that's very clear to all of you. That should be very clear to all of you that if E is in I cap direction, that means x axis, and B vector is in j cap direction, then you will get k cap as a direction of propagation. So that's why the correct answer for the given question is B. So I hope all of you are able to understand this question. So based on the same concept, I can show you one more question that appeared in NEET 2018. An EM wave is propagating in a medium with the velocity vi cap. The instantaneous oscillating electric field of this EM wave is along y-axis. Then the direction of oscillating magnetic field of the EM wave will be along. So yes, this time we have I cap as a direction of propagation. If we have I cap as a direction of propagation, now see the previous board here. So in which combination we're getting I cap in J and K, J cross K. If the electric field, see J cross K is equal to I cap. If electric field is along J cap, yes, plus y axis, that's confirmed. The electric field is along this direction. So magnetic field must be along K cap, positive Z axis. So positive Z axis. So that's why the correct answer for the given question is A. I hope all of you are able to understand this. Let's move forward to the next question. The electric field associated with an EM wave in vacuum is given by this. So in this question, the electric field is oscillating in I cap direction and the direction of propagation is Z. So where E, Z and T are in volt per meter, meter and seconds. So they are the constants. They are the variables, not the constants. The value of wave vector K is. So if you want to find the wave vector K, wave number if you can say, not a K cap, only K, that's equal to omega by V, where omega is the angular frequency and V is the velocity of the wave. So as the electromagnetic wave is moving in vacuum, it should be very clear to all of you that velocity is equal to 3 into 10 to the power 8 meter per second. This is a chapter for class 12th. Yes, Farina. Yeah, yes. So yes, electric field is given by this formula. See, how do we give the equation for the electric field in electromagnetic wave? E is equal to E naught cos or sine of kz minus omega t. Okay, kz minus omega t. This is the electric field. So we will compare this equation with the given equation. If you compare this equation with the given equation, that means 40 cos of kz minus 6 into 10 to the power of 8 into t. So in that situation, you can say omega is equal to 6 into 10 to the power of 8. radians per second. Now, next thing is we have to find K. K is equal to omega upon V. So 6 into 10 to the power of 8 divided by 3 into 10 to the power of 8, and per meter are the units for wave number. So yes, from this you can just get the values of K. K is equal to 2 per meter. So that's why for the given question, the correct answer is A. I hope you are able to understand that. And students who are getting problem, they can view a recording anytime. It's always available to you. So yes, the other question. In an electromagnetic wave, in free space, the root mean square value of electric field is given by ERMS is equal to 6 volts per meter. The peak value of the magnetic field is, we have to find the peak value of the magnetic field. What is given? The RMS value is given. So we have a relation between E and B and C. E by B is equal to C. So if you can find the E naught, that means the peak value of electric field and the peak value of magnetic field, what I'm saying, if you take E naught and B naught as the peak values of electric and magnetic field respectively, these are the peak values of electric field and magnetic field. So E naught by B naught is equal to C. So how can you find E naught? See, from E, what is ERMS? ERMS is equal to E naught by root 2. So E naught is equal to ERMS times root 2. And ERMS is how much? It's given to be equal to 6 volts per meter. So that's equal to 6 times 6 root 2. Okay, 6 root 2 volts per meter is the value of E naught. So E naught by B naught is equal to C. So this implies B naught is equal to E naught over C. And that's equal to 6 into 6 root 2 divided by 3 into 10 to the power of 8. So this means B naught is equal to 2. So 2 root 2, if you say, if you take root 2 as something 1.1, 1.1414, something approximately equal to like that, 1.414. So you will get the product to be equal to 2.8 something. Okay, let's say 83 is given in the question. So 2.83 into 10 to the power of minus 8. So, and that's Tesla, because everything is in SI unit. So we'll take the SI unit of B also. So the correct answer for the given question is A. Let's move forward to the next question. The condition under which a microwave oven heats up a food item containing water molecules most efficiently is. So a microwave oven, it contains microwaves, and microwaves can heat a substance if the resonating frequency of the substance is matching with the frequency of the microwaves. So the correct answer for the given question is A. The frequency of the microwaves must match with the resonant frequency of the water molecules. Only in that situation, it can supply its maximum amount of energy. And when the water molecules vibrate more vigorously, so they have more, see, we can say that the temperature increases. Yes. So that's why A is the correct answer for the given question. So I hope all of you got some inspiration to solve more questions like this. So thank you so much for watching the session. All the very best for your upcoming exams. So to know more how we can help you in your preparations, you can see the given link. So all the very best, students. Now we are going to end the class now. Thank you.